Hi, Michael. This is our A2 for Python for Data Analyst. The purpose of this assignment is to analyze restaurant data using Python, applying data pre-processing visualization techniques to gain insights and ultimately identify strategies to increase orders. The analysis includes detailed code descriptions and explanation of the logic behind each step. Our primary goal is to boost order volume, and our descriptive analysis will center on identifying strategies to achieve this. The files needed for this analysis are these 5 files. The first thing we did was libraries and upload files. These 5 libraries are the ones we used for each one of our visualizations and manipulation of data. This code from pandas help us read each one of the files. Now, after reading the files, we understand the data. We use shaped, info, and head, and in some cases describe to understand the dimensions, review the data of each data frame, and have some initial insights. As we can see, we made the same process for each one of the files. Then we brainstorm some questions that we'll show later.
So we grouped the orders table by restaurants and calculated the total number of orders by location. The restaurants we assessed was an NYU to have the most orders, followed by Midtown with 430,000 and 325,000 orders respectively, while Bryant Park had the least amount of orders with 227,000 orders.
Using the About code, we created an interactive map. This figure shows the locations of all the restaurants. The top 3 busiest are near major tourism and student hubs, which explains Bryant Park's low order count. This is likely due to order cannibalization by nearby Midtown and Flatiron restaurants. Columbia's lower orders, despite its proximity to Columbia University, warrant deeper analysis to uncover the cause.
For the items sold the most and least, we combine item columns into a single series to calculate the frequency of each item. So our data reveals that items like roasted sweet potatoes, snap peas, and farm greens with mint led in popularity, while protein-rich market bowls such as charred chicken and herb roasted chicken are top choices. Plant-based and pescatarian options like grilled organic tofu and wild Alaskan salmon show steady demand, highlighting potential growth opportunities. Then we left join the items table to see the items that are not being ordered, and this is the list. Looking at combos, we concatenate the main and base name. The most popular pairings are herb roasted chicken market ball or charred chicken market ball with farm greens with mint, each ordered over 280,000 times. Customers favor balanced meals that combine proteins with fresh sides like greens or grains. So key takeaways include leveraging the popularity of chicken-based market balls and promoting plant-based and pescatarian options and exploring new pairings to maintain customer engagement. These insights allow us to refine our offerings and better meet customer expectations.
Good. Now that we know what restaurants have the most orders and the most items that are sold the most, we're going to look into the type of orders that this restaurant can have. So first we grouped it by restaurants and their average delivery percentage to generate this data frame. And then we took that data frame and used this code to generate the following bar chart. And as you can see by this bar chart, that the upper, east, and west side have the highest mean delivery percentage, about 19% respectively for both of them. And Bryant Park and Midtown have the lowest mean delivery percentage, around 7-ish% for both of them as well, despite Midtown having some of the highest order counts among all of them. Another outlier in the order count we have is that the New York location has the highest average number of orders, but its delivery completion is about average compared to the other restaurants as well. Now let's look into all the restaurants combined and see the overall delivery percentage. So doing that, we made this data frame to be able to graph it in this pie chart. And we see that deliveries account for about 11%, pickups 17%, and in-store diners take about 72%. Now that we have that, let's take the above pie chart and break it down by each restaurant itself. And we see that and we generate this bar chart. This figure highlights the disparity between in-store pickup and deliveries, and it is clear based on the graph that every restaurant is relatively set when it comes to in-store pickups, with New York having the most. And again, I would like to point out just how little pickup and delivery orders the restaurants have.
So this graph shows the popularity of the cookies and orders expressed as percentages. These percentages reflect customer preferences. The 70.63 of the 76 70.63 of customers prefer no cookies nor drink in their orders. However, from the remaining 29%, 19.96% of the orders are accompanied with cookies. The drinks make up 7.89%, while both bought together are only 1.5% of all the orders.
To find our best time of day when we receive orders, first we created a copy of our original data frame to avoid modifying it. Then we converted the date time and we separated the hours into breakfast, lunch, and dinner. The majority of orders occur during lunch, accounting for over 1.16 million orders, which is significantly higher than the others. Dinner has the second highest number of orders, over 900,000, though it is substantially lower than lunch. Breakfast has the lowest number of orders, over 200,000, likely due to a smaller window of demand and fewer breakfast-oriented offerings. Then we filter the hours to lunch as it was our busiest time of day, and we have a bar chart showing the hourly trends of our lunch orders.
Okay, so now that we have all that information, let's look at the overall daily order counts across all restaurants. And in order to do this, we grouped together the date and the count of orders that happened on that date. And as you can tell by this figure, about how, or this graph shows how daily orders change over time. It seems that when the university has classes, the restaurants experience a relatively same fluctuation in orders, but during the summer months, you see a huge dip. This is more than likely because students don't have a reason to come to classes, make the trip out there to get their food, things like that.
Okay, after the analysis, we chose specific Colombia. Why? Because Colombia restaurant is relatively far from the other restaurants and has fewer orders than the others, underperforming based on its location. So we filtered this data frame for Colombia. We can do exactly the same for any other restaurant. And this is the information specific for Colombia. The top 10 most sold combos, the performance of cookies and drinks, the order distribution by mealtime that has a different pattern showing that dinner has more orders than lunch in the other restaurants. And at the end, the daily order trend that has a similar trend than the overall restaurants.
Now, what can we recommend to all restaurants beforehand? Just offer more delivery options and follow the trend that the food industry is taking up. Use a routing software, ensure adequate staffing, and improve kitchen workflows to reduce preparation times and delays in delivery percentages. We should cut items as well that are not being sold in the menu and allocate all resources for more popular items. Expand breakfast and dinner offerings so that since overall restaurants show low breakfast and dinner orders, enhance this option so that you can bring out more customers. You analyze the order trends for seasonal or behavioral shifts and customize the customer experience for each meal. Now, if we focus on Colombia, which is the underperforming restaurant, we should, during the summer season where students are most likely out of school, you could enhance a promotion specifically at lunchtime for a chicken based meal with greens. And you can just accompany it with a cookie so that it is more attractive for all of the customers.